Hi guys, this is Mrs. Tran-Bloom again. I believe this is going to be our last video for chapter 6. Anywho, we're going to start with 6.6 and this is called phase shift. Okay, so phase shift is really just moving left and right. So example 1, find the amplitude, period, and phase shift of each function. Okay, so it looks like example 1 has two functions that we're going to be working on. Graph each function. Be sure to label key points. Show at least 2 cycles. So it's pretty standard now that anytime you're graphing this out, you need to show me at least 2 full periods. Okay. Now key points, either make a chart for it or label it on your graph. So the first thing is we're going to answer the amplitude, the period, and then phase shift. So check this out. You have f of x equals 3 times sine 2x minus x. 2x minus pi. Currently, you can't really state the phase shift without factoring this out. And the reason is this. So let's talk about this equation. In algebra 2, you have y equals a times x minus h squared plus k. Remember this equation? This is your parabola equation. Okay, so check out the x. Check out the a. Notice how that's already factored out. So because you have to take the the value of x, or the leading coefficient of x, it can only be 1. If it's more than 1, or if it's anything other than 1, I should say, then you need to factor it out. So check out this right here. This is a 2 times x. Okay, so right now x has a leading coefficient of 2, so that needs to be factored out. So from here, we are going to factor. So f of x equals 3 times sine, big square bracket, because I'm going to take out a 2. If I factor out a 2, I have an x left. If I factor out 2 from pi over 2, that's really dividing. So x minus 2. Okay, so x minus pi over 2. And now we just added these other set of parentheses on this side, on the right side. So notice how instead of saying, if you don't factor it out, then you would say, hey, this is a transformation to the right by pi, which is incorrect. After factoring it out, I'm only going to shift, which is now called the phase shift, okay, to the right by pi over 2. So let's answer the phase shift and amplitude and period. So amplitude is still going to be 3 because it's an absolute value of a, so that's 3. Period. Okay. It's going to be 2 pi divided by absolute value of b. Your b value is this right here. That's your 2. That's 2x, so that's your b. So your period is 2 pi divided by 2, which is going to be a pi. What do I do with that? I'm going to go in and put a pi here and put 2 pi here, because from here to here is 1 full cycle and I need to have 2, so I'm going to do another one. So period, amplitude, check and check. Phase shift. Okay, so let's call it PS, phase shift. Okay, in the book, if you're going right by pi over 2, some of the problems state right by pi over 2. Or you can just simply say phase shift of pi over 2. So make sure you can do both. Okay, some of the problems insert the word right. Some of them just say phase shift of pi over 2. Make sure you understand that both are going to the right. Now if it says left by pi over 2, then obviously this is going to be an addition. Or if it said phase shift of a negative pi over 2, then you know that we're going to be subtracting. So that's the difference, okay? We're going to graph it out. So the first thing I'm going to do is I'm going to find the parent function. So parent function of y equals, this is sine, so sine of x. Whoop, and whoop. There you go. A handful, right? A handful of inputs. Here we go. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are my 5 inputs. So the outputs at 0, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and back at 2 pi is going to be 0. Now we're going to have all the transformations. So this is a vertical stretch by 3. Okay, so actually, let's focus on this one right here, because this is the factor one. This is a vertical stretch by 3, so you know that's going to change my y. Oh, that is one ugly line. Sorry, that wasn't crooked. I mean, that wasn't straight at all. Okay. Alright, as I'm fixing this line, let me tell you a joke. Alright, so my husband is a criminal defense attorney. So some of you don't know me, especially if you're from another teacher's class. So he's usually, you know, defend people that's guilty or not. So remember, the law says innocent until proven guilty. So he defends people. So this kind of reminds me of his career. So a man was released from prison. So he came out and he's like jumping for joy. He's like, hooray, 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 yay, I'm free, I'm free, I'm free. And then a kid came up and said, so what? I'm 4. You get it? It's a toddler joke. Okay, so the kid thought this guy is saying I'm 3, but really he's saying I'm free. So he's 4, so he didn't think anything of that. So anyway, that's my awesome toddler joke of the day. Moving on to this one. My bad. Vertical stretch factor of 3. So that's going to be 3y. This is going to be a horizontal... Horizontal what? Can you tell me? This is a horizontal compress. Okay, that means I'm going to multiply the x by 1/2. So a compression means you have to multiply something that's less than 1. This is, we just said it earlier, it's a phase shift right by pi over 2. So I'm going to add a pi over 2. Okay, so here we go. 0 times 1/2 is 0. 0 plus pi over 2 is now a pi over 2. Pi over 2 times 1/2 is a pi over 4. Okay, so here's a pi over 4 plus a pi over 2. Well, pi over 2 with the common denominator of 4, then I would have to multiply this by 2. What I multiply to the bottom, I multiply the top by 2. So a pi over 2 with the denominator of 4 is really 2 pi over 4. So if I could add that, I would end up with a new input of 3 pi over 4. So that's really, these are my 2 new inputs. So let's check out the difference. Pi over 2 with the denominator is 4, so that's really 2 pi over 4. Would you agree? So from here to here, if you look at it, the difference is a pi over 4. So as you remember, I'm pretty sure I mentioned this before, that math is really a big pattern, right? Mathematics is really a pattern. So if I have 2 pi over 4 and this is 3 pi over 4, my next input is really going to be 4 pi over 4, okay? Which is really simplify that down to a pi, okay? So let's look to see if we're right. So pi over 2 times a pi, that's going to be pi over 2. Pi over 2 plus pi over 2. It's going to be 2 pi over 2. 2 pi over 2 reduces to a pi, and that's what we're going to have. Okay. The next one is if I'm going to add another pi over 4. It looks like from here to here, we're just adding a pi over 4. So it's going to be, this is going to be 4 pi over 4. So if I add another pi, so this is going to be 5 pi over 4. If I add another one, it's going to be 6 pi over 4. But 6 pi over 4 reduced down to 3 pi over 2. Then I'm going to add another one. Do I have 5 yet? 1, 2, 3, 4, 5. Yep, I do. Okay, so I have 5. And then the outputs, right? 3 times 0 is 0. 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. 3 times 0 is back at 0. So these are all the inputs that I'm going to use for graphing. Okay, so here we go. Every period needs 4 equal intervals. Okay, so let's label the tick marks. This is from here to here is pi. So right smack center is pi over 2. And then from here to here is pi over 2. So right smack center is pi over 4. So this is pretty much 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Because I need to have I need to show 2 full cycles, then that's why I have 2 pi label here. Okay, let's graph. 2 pi over 4, or aka reduced down to pi over 2, I'm saying it's 0. Okay, and that makes sense because if you look at this, I'm moving to the right by pi over 2. So usually sine starts at 0, 0. But because I'm moving right by pi over 2, so now at pi over 2 comma 0. 3 pi over 4, which is one tick mark over, I have to go all the way up to 3. And you do need to make your tick marks for y, because I notice a lot of you don't do that. How would I know if that's a 1 or 3 or 5 if you don't have anything labeled on the y-axis? Then at pi, staying at 0. Then this one right here at 5 pi over 4, 1, 2, 3, negative on the bottom, staying negative. Then 3 pi over 2 is going to be at a 0. My bad. Okay, so that's one full cycle, right? Okay. Because I have a chart here, I don't need to do any labeling here. Now, if you decide to not do a chart, then you have to give me some points on the graph. Well, I need to do 2 full cycles. So I'm going to continue the pattern. Here we go. Okay, that's a cycle and a half. I don't have any more room on the right, so I'm just going to go to the left. And hey, you can go whatever way you want to go, as long as you give me 2 full cycles. Okay? And that's a beautiful 2 full cycles graph. Alright, now we graphed it, we stated the phase shift, we stated the period, we stated the amplitude, we labeled the key points, but I have a chart, so I don't need to. And I think we're pretty much done. Okay. Alright, let's move on to B or B. Okay, so first let's state all of the amplitude, the period, the phase shift, okay, that they've asked for in the direction. But before we do that, what do we need to do with this function? What is the most important thing? Is there a leading coefficient on the x that we need to factor? Yes. Okay, so factor it out. Since I'm kind of running out of space, I'm just going to use this piece above. F of x equals 2 times cosine, big bracket, let me get a new pencil, 4 times x plus, right? If I'm dividing each and every term by 4, so this is really a 3 pi over 4. Close it with a square bracket, 2 plus 1. We have a lot of things going on. We have a vertical stretch by 2, a horizontal compressed by a 4, a left by 3 pi over 4, and an up by 1. Okay. Period and amplitude. There we go. Period. It's going to be 2 pi divided by 4. 2 pi divided by 4, which is a period pi over 2. Awesome. So here's a pi over 2. And if I want 2 full periods, it's going to be a pi. Let's go and put 4 equal intervals on here. 4 equal intervals. Okay. Well, from 0 to pi over 2, right smack center is going to be pi over 4. Right smack center of 0 to pi over 4 is pi over 8. Okay. So each tick mark is worth a pi over 8 unit long. Amplitude. Okay. This is a 2, so my amplitude is going to be 2. Phase shift. PS. Okay. This is going to be a left by 3 pi over 4. So phase shift negative 3 pi over 4. Okay. Or you can say left by 3 pi over 4. If you're using the word left, then you don't need to put the negative in the front. But if you don't use the word left, then you have to put a negative in the front. Okay, so we have a parent function of y equals cosine of x. Can you guys see that okay? Then let's give my 5 inputs and outputs. Here we go. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So cosine of 0 is going to be 1. Cosine of pi over 2, 0. Cosine of pi, negative 1. Cosine 3 pi over 2, 0. Cosine 2 pi, 1. Alright. And then I'm going to, I'm out of space. Where would I put my transformation chart? Alright, let's do it here. Let me get a different color pen because I don't want to, here we go. Okay. I'm probably going to do, oh, is that working? Okay. X. Okay. Let's check out what's changing the x value. This is a horizontal compress by a quarter, so multiply x by a quarter. In addition, I have to subtract 3 pi over 4. That's really squeezing that in there. Okay, there you go. The y, I have a vertical stretch by 2 and an up by 1. So 2 times y plus 1. So that's really all the stuff I'm going to multiply to y, and all the stuff I'm going to do to x. 0 times a quarter is 0. Take away 3 pi over 4 is negative 3 pi over 4. Okay. Pi over 2 times a quarter, that's going to be pi over 8. Okay, so let's talk about this. Pi over 8. Pi over 8, so let's write it in pencil. Well, I'm subtracting 3 pi over 4. Because I have a denominator of 8, I need to convert 3 pi over 4 to denominator of 8 as well. So I'm going to multiply this denominator by 2 to get 8. That means I need to multiply the top by 2 to get 8. So if I subtract this, pi over 8, take away 6 pi over 8, is really going to give me a negative 5 pi over 8. And I just have to be very careful because I'm really running out of space. Now let's talk about this. Negative 3 pi over 4. If I were to convert it into denominator of 8, that's really a negative 6 pi over 8, right? So let's see the trend or the pattern. From negative 6 pi over 8, the next one is negative 5 pi over 8. So I'm really adding by a positive pi over 8, or I'm really moving by a pi over 8. So that means if I'm moving a pi by a pi over 8, I can't really speak, a pi over 8, then the next one would be a negative 4 pi over 8, which just really reduces down to negative pi over 2. Okay. Then I'm out of space. Let's make it over here. And do okay, 1/4 times x minus 3 pi over 4. This is just a continuance, okay? Because I'm just out of space. And this is really 2y plus 1. All right. Then the next thing I'm going to have is, hey, from 5 pi over 8, 6 pi over 8, negative 6 pi over 8, negative 5 pi over 8, negative 4 pi over 8. This is really negative 3 pi over 8, which I can't reduce. 1, 2, 3, 4. I need one more value. And the next one to be a negative 2 pi over 8, which reduces down to a negative 1/4 pi. Okay, so those are 5 inputs after these two transformations. All right, next, outputs. 1 times 2 is 2, plus 1 is 3. 0 times 2 is 0, plus 1 is 1. 0 times 2 is 0, plus 1 is... Oh, I'm sorry, I missed that one. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. 0 times 2 is going to be 0, plus 1 is going to be 1. And last one, 1 times 2 is 2, plus 1 is 3. So all the inputs and outputs, okay? Looks like I have to go all the way to 3. So 1, 2, and 3. And then I have to go as low as negative 1. So there's my y. Notice I have a lot of stuff on the right that's positive, but all of my graphs right here, if you check this out, it's all negative, right? So I just have to go and put in, looks like I need all the way to negative 6 over 8. So here we go. Negative 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, and 6 pi over 8. When you are out of space, don't be shy to go left and right and extend your x or y axis. Remember, I typed up these notes way beforehand. There's no way I could have guessed what it's supposed to look like. So make sure you can always re-sketch your x and y coordinates, okay? Or x and y axis, I meant. Alright, so if each tick mark is worth a pi over 8, then this is a negative pi over 8. Okay? Negative pi over 8, 2, 3. So my first dot is going to be negative 6 pi over 8. So 1, 2, 3, 4, 5, 6. I need to go all the way to 3. Can you see that right there? Okay. The negative 5 pi over 8, which is one tick mark over, staying at a positive 1, which is right here. This is now negative pi over 2, which is really 4 pi over 8. I'm going to go to negative 1, which is on the bottom. Then over here, negative 3 pi over 8, staying at positive 1. And negative pi over 4, which is 2 pi over 8, go all the way back to 3. So this is one full cycle here. And remember, these are not V shapes, okay? These are like, you need to round out the bottom and the top. Sorry, that looks kind of ugly. Okay, arrows at the ends. Okay, so these are the dots. I want to make sure they look okay. And I'm just going to continue a little bit more because that's only one period. I just have to go a little bit further. So positive 1, negative 1, positive 1, 3. So that's really two full cycles here. Okay, but because I already have these SketchUp, I'm just going to go further. You can always go more. I'm not going to take points off for going more, but I will take points off for not having enough. So that doesn't look like one. There you go. All right, that looks in the blue ones, the blue dots are just extra dots that I just happen to have. So technically, the pencil piece is really a 2 full cycle. The blue, just because I have it labeled, it feels kind of wrong to just leave it by itself. So I just kind of continue that out. All right, so with that, let's see. Did we answer everything we need to answer? Okay, amplitude, check. Period, check. Phase shift, check. Craft, check. Key point, which is the table, check. All right, 2 full cycles. We have more than that. So we are good. All right, don't stop right here. We're going to go all the way to the end of 6.6, which is now example 2. Okay. Example 2. Let me just zoom in on A because it's really tiny. Example 2. Find the answer to each. 1. Find the amplitude. 2i, state the period. 3i's, phase shift. Okay, so let's check this out. Y equals -1/2 times sine of 4x plus 3 pi. So remember, if you see a leading coefficient in front of x, you should really do what? You start with an F, and no, it's not a bad word. Factor, right? So we're going to factor this out. So this is really what we get if you factor it out. So the amplitude is this first piece, so it's an absolute value of A, so the amplitude is 1/2. So if I look at my choices, A, B, C, D, they all have 1/2, -1/2. Oh, that's not right. Okay, cross out B. Oh, 2. No, that's not right. So right now, your 2 correct choices can either be A or D. Next, find the period. Period is really 2 pi divided by absolute value of B. Well, your B is 4, so 2 pi divided by 4 is going to be pi over 2. Okay, so now I only have 2 choices left to determine. Well, it can't be 4 because I just found it and it says 2, so that one's not right. So really, my correct answer is A. And let's talk about the phase shift, right? Notice how they're using the negative here. This is the left by 3 pi over 4, or according to the previous example, I said you can also do a negative 2 pi over 4 phase shift. And that's also correct, just to confirm. Let's move on to B. All right, here we go. Let's zoom in a little bit. The graphs are really small. All right, here we go. So it's really just asking you which one's the best function for this, okay? Now what we need to do is look at the 4 choices, okay? We have an amplitude of 3, okay? There's no vertical shift up or down. So none of these should be moving away from your x-axis, which is the center. So right away, we know that A can't be and C can't be because it's moving away from the x-axis. It's shifting, okay? It's moving the graph and moving it up, which the equation doesn't say so. All right, so the next thing is, hey, which one is the cosine function, okay? And which one has an amplitude of 3? So if I look at this from the center, 1, 2, 3, that has an amplitude of 3. And this also has an amplitude of 3. So both of them could be the right choice. The next one is really now to see if there's a coefficient with the x. Let's factor that out. So y equals 4 times cosine, big bracket, pull out the 4. Just to see if there's a phase shift of any sort, okay? So if I factor out 4, that's really dividing by 4 multiplied by 1/4. So a half times a quarter or 1/4 is really pi over 8. Oops, you can't see that. There you go. All right, my 2 choices are now just simply B and D. Now which one's correct? Cosine, the parent cosine is 0, 1. So if I have y equals 4 times cosine of x, just taking this first piece right here, then I should have a 0, 4. Okay, so technically that's correct. But you do have a phase shift to the left by a little bit, right? left by a pi over 8. So if I go left by pi over 8, this should be the better choice and not this. Okay, this right here is perfect if you don't have any phase shift, but because you do have a phase shift, your choice is B. And that's really how you guys do multiple choice. Okay. Now, this is the conclusion of Chapter 6. Are you excited? Chapter 7, Mrs. Lassner is going to do all of the recording, so you're not going to hear me anymore until Chapter 8. All right. Until next time, until Chapter 8, and see you guys around.